السلام عليكم ورحمة الله تعالى وبركاته. فعندنا مثال في differential equations هنحله بطريقة الباور سيريز. يعني لو عندنا مثال بالشكل ده y double prime, that means the second derivative of y minus y itself equals 0. So to solve this equation, so we have let y equal sigma from 0 to infinity an x to the power n. If now we differentiate this, we give 1 prime, the first derivative equal, I think it's here, y prime equal from 1 to infinity n multiplied by a n x n minus 1. Okay? And if we differentiate the y prime, you will get y double prime or the second derivative. Y double prime equal sigma from 2 to infinity. That means n multiplied by n minus 1 a n x to the power n minus 2. Okay? And our question is that to find prove that y double prime minus y equals 0. Okay? So here y double prime minus y equals 0. Instead of y double prime, we have to put here this. Instead of y double prime, we put sigma from 2 to infinity n minus 1 n minus 1, but then a n x n minus 2 minus from 0 to infinity a n x to the power n. This is y, so it should be equal 0. Equal 0. Okay? 0. Equal 0. Okay? Now, here x to the power n and here x to the power n minus 2. So we try to make this power is also n only n instead of n minus 2. Now, this is n minus 2, okay? N minus 2. If we, so n will be shifted to be n plus 2. Here, n should be n plus 2. Instead of n, you have to replace it by n plus 2. So if you put here n plus 2 minus 2, okay, plus 2 minus 2 will cancel each other, so this will be n. So this power will be n. Okay, here instead of n, here you have to put n plus 2, and instead of n here you have to put n plus 2, and instead of here it will be n plus 1. Okay, and instead of here will be 0 because n equal to instead of n, you have to put n plus 2. N plus 2 equal to, that means n equals 0. So after making all these change, the derivative, the equation like this, sigma from 0 to infinity, here n plus 2 multiplied by n plus 1, a n plus 2 x to the power n minus, here from 0 to infinity, n a n x to the power n. So these terms, this is equal 0. Okay? So the common factor of these terms is sigma x to the power n. So this will be, if we take sigma, from 0 to infinity x to the power n as a common factor, this will be equal n plus 2 times n plus 1 a n plus 2, okay, plus 2, here should be minus a n equals 0, okay? After rearranging this equation, we'll have an plus 2 equal an divided by n plus 2 n plus 1. Okay. So let us, start with n equals 0. That means an plus 2, an plus 2, it will be equal a2. So that means a2 equal, instead of n put 0, that means equal 0. Here 0 here 2, 0 plus 2 equal 2, 0 plus 2. That means 2. That means 2 factorials. So a2 equal a0 over a factorials. Now let us do the even indices first. So then if you take n1, n equal 1, no, equal 2, n equal 2. So this will be 2 plus 2 equal 4. So A4 equal, here will be 2. So A2 over, here 2 plus 2 equal 4. Okay? With 2 plus 1 equals 3. That means 4 times 3. Okay? And we have A2 equal A0 over 2 factorial. So if we substitute this with this value, so A4 will be like this. Okay? A4 should be like A0 also plus 4 factorial. This is A4. And A6, similarly, A6 will be A6 will be A0 over 60 factorial. So the even indices will be like that. Okay, A0 over 2 factorial, okay, plus A0 4 factorial plus A0 6 factorial and so on. Okay, if you take A0 common factor, so A0 is the common factor, this will get the following. So here A0, here that means x squared over 2 factorial. Here plus x4 plus 4 factorial. 4 factorial. And this will be x to the power 6 factorial. Okay? Now, let us, this time we will try the odd indices. So, okay? Right. The first term of the odd indices is A3. A3. A3, that means here we have A n plus 2. All right? When if n equal 1, that means this will be A3. So in this case, n equal 1. Sorry, n equal 1. So A3 equal, okay, equal A1 plus over 3 factorial. Okay, then A5 equal A1 over 5 factorial. Sorry, 5 times 5, oh no. Yeah, sorry. A5 equal A1 over 5 times 4. So if you just a minute. Okay. We already have A n plus 2 equal A n plus 2 n plus 1. Okay? So if we take n 1, that means this is A3. A3 equal A1 1 plus 2 equal 1 plus 2 equals 3. 1 plus 1 equal 2. This is 3 times 2. This is should be that this is equal what? A3 equal A1 over 3 factorial. So A1 and 3 factorial. So A5, when say A5, that means n equal 3. Okay? A5, A5 equal A3 over 3 plus 2 equal 5, 3 plus 1 equal 4. That means 5 multiplied by 4. And we have A3 equal A1 over A3. So in this case, A5 will be A3, so here, A5 will be equal A1 over H over 5 factorial. Okay? Also A7, A7 equal A5, A5 على 5 plus 2 equals 7 multiplied by 6. And we have also A5 equal A1 over factorial. So the final answer like this. The final answer like this. A3 equal A1 over 3 factorial plus A5 equal equal A1 plus 5 factorial plus A7, that means equal A1 plus 7 factorial. So the final solution of this differential equation is like that. The final solution will be like that. Y equal A0, so that x square over 2 square plus x4 over 4 factorial plus x to the power 6 plus 4 factorial over 6 factorial. Okay? This one. Plus A1. Here, A3 should be equal A1 over 3 factorial plus A1, plus A1 over 5 factorials plus A1 over 7 factorials. So, and this function here, this one is equal A0, A0 push x, this one, plus A1 here, okay, A1 shine x, okay. And now we have, so the final answer is like that. Y equal A0 push x plus A1 shine x, and this is hyperbolic functions. Okay, trigonometric not the circular functions. This is hyperbolic functions. So for y equal c e to the power x plus c e to the power minus x. So it can be written like this. Because cos x equal cos x will be equal e to the power x minus e to the power, cos x cos x would be equal e to the power x minus e to the power minus x over 2. And shine x equal e to the power x plus e to the power minus x over 2. So this is I hope I have explained it not less than 75%. Okay, thank you.